In this example, we're going to learn how to find the critical chi-square values for different types of hypothesis tests. Um, we don't have any calculator entries to show, so I'm not really sure why I wrote that, but we're going to show appropriately labeled and shaded graphs. And any work that we need to do here. Okay, so let's see here. We have a two-tailed test of a standard deviation with alpha equal to 0.10 and n is equal to 61. So for a two-tailed test, let's go look at the inferential statistics sheet for a second. So we want to find the critical chi-square values. We're going to need the chi-square table. And a two-tailed test is the most complicated of all of them because you have to have alpha over 2 in each tail, and then alpha over 2 is one of your critical values, and 1 minus alpha over 2 is the other one. So we need to figure out all of that stuff. Let's start with the degrees of freedom. We know it's n minus 1, which means that it's 60, right? Because 61 minus 1 is 60. Everybody knows that. All right, that will be the row of our chi-square table that we're going to need. And since we need two critical values here, we need two columns to look at, just like in chapter 9 when we were doing confidence intervals. So we take 0.10 and we divide it in 2 and we get 0.05. And then we take 1 minus 0.05 and that gets us 0.95. All right, then we have column number 1 and column number 2. All right, so let's go look at the chi-square table real quickly. And here it is. And we want 0.05, I believe, and 1 minus 0.05, which is 0.95. So 0.05, and we want 60 for our degrees of freedom, which is kind of down here, right in the middle, 79.082. And then we want it again for 0.05, or 0.95, excuse me, and that would be 43.188, right there. There is no calculator option here, so this is it. You're going to have to use the table. So 60 degrees of freedom, 0.05 and 0.95. Notice, by the way, that they're 2 away from that center line. All the ones on the right side of the center line are on the right side of the curve. All the ones on the left side of the center line are on the left side of the curve. Okay, so let me go put those in. There we go. And we're done with that one. Simple as that. 43.188 on the left, 79.082 on the right. All right, what about the next one? Well, let's see. We have alpha's 0.01. This one's kind of nice. They gave us the degrees of freedom. So they tell us that it's 12 right off the bat. No need to subtract or anything. Then they tell us that sigma is greater than 14.2. So that means that we're looking at sigma greater than something would be a right-tailed test. So we need to look at the right-tailed picture that uses alpha. So alpha's in the right tail over here. So this is 0.01, that's alpha. And I'm looking for that chi-square value. So I definitely need to have the 0.01 column for the table. I don't need to split it in half this time. I'm going to use all of alpha because it's a one-tailed test. No need to cut it in two. All right, so let's go to the table. 0.01 column, degrees of freedom is 12. That's right here, that's 26.217. So I'll go put that in. And we're done with that. These tables are really quick and easy to use if you know what you're looking for. Oh, and there's no other column, so that's just the column we need in general. All right, so I'm going to copy and paste all of that for the last test. Now the last test is not a right-tailed test, it's a left-tailed test. So you can see it's less than 29 for the alternative hypothesis here. So if we look at the inferential statistics sheet, when you have a less than, that's left-tailed. So we need this graph over here where alpha is the area in the tail, but 1 minus alpha is the part that we're looking for in the columns for the table. So let's start with degrees of freedom. Degrees of freedom is 28 take away 1, which is 27. So there's our degrees of freedom. And then I know that alpha here is 0.005. Okay, but that's not the column that I want. What I want is 1 minus alpha. Now, why is that? Well, if you recall, these tables work off of the area, the area in the right tail. That's how the tables work, right? It says right up to the top, area to the right of the critical value, the right. So if you're over here on the left-hand side, oops, there we go. Over here on the left-hand side, the area to the right is 0.995. So I'm going to grab 0.995, that's my column right there. And there we have it. There's the column we're looking for. Okay, so row number 27, column 0.995. Let's go grab the table. 0.995, column or row number 27 is 11.808. This would be 0.995, comma 27. And that was 11.808. And there we have it. That's how to find all the critical values you need for both a left-tailed, a right-tailed, and a two-tailed test. And remember, if ever you get lost about, is it 1 minus alpha or is it alpha, always look back to your inferential statistics sheet because it tells you right in here which one you want. Right-tailed test, you want alpha. Left-tailed test, you want 1 minus alpha. Two-tailed test, you need alpha over 2 and 1 minus alpha over 2.